In this video, we're going to talk about mole-to-mole stoichiometric conversions. So in this equation here, two Al2O3s decomposing to make 4 aluminums and 3 oxygens. Another way to say this is each time we use 2 moles of aluminum oxide, we're going to make 3 moles of oxygen. So you can show this in a bracket in one of two ways. There's always two conversion factors that you can make from any truth. I can have 2 moles of aluminum oxide over 3 moles of oxygen, or I could have 3 moles of oxygen for every 2 moles of aluminum oxide. This is just the same as saying there's 12 inches in a foot, or 1 foot is 12 over 12 inches. They're both this true statement, so it doesn't matter which way you arrange it. When you're doing conversion problems, it's up to you. It's your choice of how you arrange it correctly to convert from the thing that they're starting you with to the thing that they're asking you to solve for. Let me show you how in a specific question here. So if they asked you how many moles of oxygen are produced when 3.4 moles of aluminum oxide decompose, they have to give you the balanced chemical equation like this, so they have to give you a way to get to this part. But we're going to use the number that they started us with. They gave us in the problem 3.34 moles of aluminum oxide. We always start with the one piece of information that they give you. Okay, then we want to convert to moles of oxygen. They say how many moles of oxygen do we make when we have this many moles of aluminum oxide decomposing. So the way you set up your brackets, you want to have the units above and below cancel, and the unit that you want to turn it into has to be on top here. So they're asking for moles of oxygen, so that tells me I want moles of oxygen on the top and moles of aluminum oxide here on the bottom. So we get the numbers straight from the balanced chemical equation. So we have 3 moles of oxygen, according to this balanced chemical equation, for every 2 moles of aluminum oxide. I could have flipped it around. I could have said 2 moles of aluminum oxide for every 3 moles of oxygen. That's a true statement, but that math wouldn't give me the right answer because my units aren't lined up right. I want to cross off moles of aluminum oxide with moles of aluminum oxide to leave me with moles of oxygen. If I did it the other way around, it would leave me with moles of aluminum oxide, which is not what I want. They've already started us with that. Okay, so like I said, it's really up to you to pick the right bracket in order to solve these problems correctly. Now, the key to getting this right, to doing it correctly, is to always write your units. The biggest mistake I see on kids that do problems, conversion problems, is if they don't write the units, the numbers completely lose their meaning. When you just start writing 3 over 2 or 2 over 3 without the ability to double check that these things will actually cross off, you can lose yourself really quickly in the problem. Okay, but I didn't do that. I wrote the units. I can see they cross off. I see that I'm left with moles of oxygen. That's exactly what the question is asking us for, moles of oxygen. So I know it's time to punch this into my calculator. Whenever we're doing a problem like this, we multiply by everything on the top. So in your calculator, you will type 3.34 multiplied by 3, enter, divided by 2. Or you can do it all at once. 3.34 times 3 divided by 2. Of course, we divide by everything on the bottom, and that will give us 5.01 moles of oxygen. Okay, let's do this practice problem here. If 3.84 moles of C2H2 are burned, how many moles of oxygen are needed? So again, always start with the one piece of information they gave you. They tell us that we're burning this specific amount of C2H2. Now, I mean, this problem would be really easy if they just said, okay, if we burn 2 moles of C2H2, how many moles of oxygen are needed? Well, 5. It says it in the problem. The ratio says for every 2 we need 5. If they said, okay, well, what if we doubled it? What if I said we burn 4 moles? From baking and things like that, you would just have to double this. If I doubled this ingredient, or reactant, I would have to double this one. Okay, but what if they do this? And they say, okay, I have 3.84. That's when you need the stoichiometry to solve these. Okay, so we're going to start with the 3.84. We're going to set up a bracket. Now I want moles of C2H2 on the top to cross off with moles of C2H2 on the bottom, and I want to turn it into moles of oxygen. That's what they're asking us for. How many moles of oxygen are needed? So I'm going to use the molar ratio straight from the balanced chemical equation that they gave us. So there's 2 moles of C2H2, so I'll put that on the bottom, and there's 5 moles of O2. I'll put that on the top. And you'll see that the moles of C2H2 cancel the moles of C2H2. I'm left with moles of oxygen, which is what they're asking us for, so I know it's time to go to the calculator. So in your calculator, you'll type 3.84 times 5 divided by 2, and that is 9.6 moles of oxygen. Okay, let's do one more. How many moles of C2H2 are needed to produce 8.95 moles of H2O? So start with what they give you, set up your bracket, use the mole ratios that you see in the balanced chemical equation in front of you, and solve this one on your own. And when you're ready, I'll solve it. Okay, so again, we start with what they give us, 8.95 moles of water, and then we set up a bracket. I want moles of water to cancel off, so I'm going to put that on the bottom. 2 moles of water on the bottom, and I want to turn it into moles of C2H2. I can see that there are 2 moles of C2H2 for every 2 moles of water, so I'll put 2 moles of C2H2 on the top. Okay, so multiplying by 2 and dividing by 2 is really dividing by 1, or multiplying by 1, so my answer, of course, is going to be 8.95 moles of C2H2. Okay, one more. If 2.47 moles of C2H2 are burned, how many moles of CO2 are formed? Again, give this a try on your own. Pause the video, and when you're ready, I'll show you how it's done. Okay, we're going to start with what they give us, 2.47 moles of C2H2, and we're going to set up a bracket. I want the C2H2s to cancel, so I look at the mole ratio from the equation, and I see there's a 2 there, so I'll plug that in at the bottom. And I'll remind myself that what are they asking us to solve for? Moles of CO2. So I look to my equation, and I see the ratio is for every 2 moles of this, I make 4 moles of this, so I'll plug that in the top here. My moles of C2H2 will cross off with my moles of C2H2. I'm left with moles of, oh, this should say CO2. This is a typo. I have 4 moles of CO2, not O2. But if you do 2.47 times 4 divided by 2, you will get 4.94 moles of CO2. So the steps that we follow to calculate any stoichiometric problem, at most there are 5. So step number 1 is you need to correctly balance the equation. So far, every equation that I've given you is balanced, and they most often will be. The second step is to convert whatever the given amount is into moles. Now, the problems we just did started in moles, so we didn't have to do this step. But if it wasn't, like if they started you with grams, your very first bracket would be to convert to moles. Step 3 is to set up the mole ratios, and this is what we did. We went to the balanced equation and we looked at the ratios of the moles in the equation, and that's what we used for our bracket. Step 4 is to use those mole ratios to cancel off the moles of what you have to the moles of what you want, your desired chemical that they're asking about in the problem. And step 5, if necessary, is to convert moles back to the final unit. In the last couple problems, I was asking you for moles, so we didn't need to do this. But if I was asking you for grams or atoms or something like that, you would have to do one more conversion factor. We'll talk about those in an upcoming video. So in summary here, when doing mole-mole calculations, always start with the one piece of information that they give you, and then use the mole ratio from the balanced equation to convert from the moles of the chemical you start with to the moles of the chemical they're asking you for. And if you write your units and labels every time and cross off as you go, this should be no problem for you.